Hello, my name is Aaron Lima. I'm a Principal Solutions Architect here at AWS. And during this webinar, we're going to focus on managing Windows workloads on AWS, but specifically day two operations. Well, what are we talking about with day two operations? Well, customers, when they typically bring or migrate a workload into AWS, they're looking to lift and shift. They want to keep it the same. It's either a consumer-based, off-the-shelf application or something that they've built and care intended for many years. However, on premises, they were focusing on making sure that they patched that workload correctly, they were monitoring it, and also making sure that it met to a certain configuration standard. And when they come into AWS, they either ask before they migrate or after how they continue to use those services or continue to do those actions inside of AWS. And so that's what we're going to talk about here today. How do you do patch management, monitoring, and configuration management for Windows workloads in AWS? And the answer comes down to there's a bunch of services that we provide that make it simple to really manage or operate your Windows workloads inside of AWS. A couple of them here you can see. One of them is Amazon EC2 Image Builder, which focuses on creating standard images, or what we call inside of AWS Amazon machine images. However, Machine Builder can allow you to also create those images and push to on-premises as well. There's also Launch Wizard that allows you to simplify deployments of things such as SQL or Active Directory. But what we're going to focus on in this workshop is on the last two items, which is Amazon CloudWatch, which is monitoring your workloads, and also AWS Systems Manager. So let's jump into AWS Systems Manager. Operating your application and resources in any environment with agility and scale and control is critical in the cloud, or critical to accelerating application development and deployment. And us in IT, we want to help to support business transformation and agility without compromising governance and stability. And so when we look at Amazon Systems Manager, it allows teams, regardless of whether they're traditional IT shops or DevOps shops, a tooling base which they can create standards inside their organization. And if we take a look at this graphic here, you can see that any environment, that could be an AWS environment, on-premises, a container or serverless environment, edge, any of those workloads can be managed and maintained using AWS Systems Manager. Now, AWS Systems Manager helps customers to really build a foundation, and it really starts with the quick setup. We're not going to demonstrate the quick setup today, but when you get into Systems Manager, if you want to get things configured and set up quickly, there's a quick setup wizard. That quick setup wizard will help you to set up things like inventory, some type of automation, be able to get your patch management set up, but they all help to enable operational best practices and continuous compliance. Now let's talk about a couple of the features inside of Systems Manager. One of those features is Run Command, and we'll be using this in the lab today. Run Command allows you to remotely execute scripts against EC2 instances or on-premises instances in a secure manner. Everything is tracked via CloudTrail, and you can control what somebody does via IAM. And you don't need any SSH keys, Bastion host, or any of that in order to do this. This allows you to install or bootstrap applications and to do it at scale. And so in the lab, we'll look at doing that across our IIS web servers that we have deployed inside of our lab. Then there's also Session Manager. So let's say I need to get into a machine and troubleshoot it. I need to be able to collect logs because maybe I'm not grabbing those logs via CloudWatch or some other tool. And I need to just kind of see what the lay of the land is on my instance. I need a break glass mechanism. Well, that's where Session Manager comes in. It allows you to securely connect to your EC2 instance console and be able to run commands right on that EC2 instance, or again, on premises. All actions can be tracked and monitored, and all those actions can be dumped to an S3 log. And again, via CloudTrail and IAM, we can control what folks do. So in the lab, you're going to use this to kind of troubleshoot one of our EC2 instances that we've deployed. Again, this enables a break glass investigation and remediation for DevOps teams or even traditional IT teams. The next question that customers ask is, well, how do I track what software is installed on my EC2 instances? Well, that's where EC2 Systems Manager inventory comes into play. So here with inventory, we can collect data on what's installed inside of those instances, how registry keys, what files, etc. So in the lab, we're also going to create an inventory schedule so that we can gather that data and take a look at some of the information that it provides. Next, when we write scripts or we do anything at scale, one of the things that we don't want to do is hard code items or information to our scripts. It doesn't make it reusable or flexible. But using something like Systems Manager Parameter Store, we can centralize that configuration data and can control who has access to it. That some of that data can be secure passwords, or in the lab, it can be things such as CloudWatch configuration. And again, this is all controlled and audited. Next, we're going to take a look at State Manager. Now, State Manager simplifies our ability to push standard deployments or configurations. It's a really good tool with tools such as Ansible or Chef, but in the lab, we're going to focus on using State Manager with a PowerShell DSC configuration to make sure that our instances are joined to a Active Directory domain. And we'll see how it reports on configuration drift or whether we adhere to a standard and make sure that our configuration happens. And then Fleet Manager. If we have thousands of machines or hundreds of machines, and we want to quickly see what files are in a machine, what's going on, what is its audit, what's the patch level that it's at, all of that can be done via Fleet Manager. It allows us to have that consistent administration across our entire fleet, again, whether it's in AWS or it's on premises. And then finally, Patch Manager. Patch Manager is a service inside of, or one of the features inside of Systems Manager that allows you to be able to automate patch remediation and also to report on your compliance level of patching. Now, one of the things to keep in mind and why Systems Manager is one of my favorite services is that it's just like a Swiss Army knife. There's so many tools and features available in Systems Manager that allow us to do a lot of things inside of our AWS ecosystem. And we've only touched on a few, and in the lab, we've only touched on a few. But there's also integrations that Systems Manager has with services such as AWS Config, Amazon Event Bridge, CloudTrail, which all its audited actions, and also IAM to be able to do role-based access control. And so in the lab, I've kind of alluded to this as we've gone along the way, but you're going to use run command to remediate IIS. We're going to use session manager to log in and pull logs. We're going to use patch manager to manage the patches on our Windows EC2 instances. And then finally, we're going to use state manager so that we ensure that those Windows EC2 instances are joined to an Active Directory domain. Now, we talked a lot about patching and configuration, but what about monitoring? Well, that's where Amazon CloudWatch comes in. Now, here at AWS, we don't really like to talk about monitoring, but we like to talk about observability. And observability, as you can see here from this Wikipedia definition, is a measure of how well internal states of a system can be inferred from knowledge to its external outputs. Well, what does that really mean, brass tacks? Well, monitoring, that tells us whether a system is working or not. But observability lets us understand why it isn't working. And a good observability strategy allows us to answer the questions that we didn't even think to ask or need to ask. And so some of the tools that fall into observability are tools such as X-Ray, which gives us a 360 view of our or a service map of our application. What are the API calls happening to other AWS services, maybe microservices as we continue to modernize, so we can really hone down on where the problem might be. Then we need to dig a little bit deeper. And so we need to investigate and correlate logs. And that's where CloudWatch logs and log insights inside of CloudWatch come into play. And then finally, metrics. What is our CPU usage? What's our memory usage? What's our free disk space if we're managing an EC2 instance? That will all come through these CloudWatch metrics. And again, we can do metric math or filters on any of these items to get alerted. And so when we look at it, it's kind of like a three-legged stool. So right now in today's workshop, we're going to focus on two of those legs, which is metrics and logs. But we encourage you to take a look at X-ray traces. And at the end of the lab that we have, there'll be a bunch of additional links to other workshops that can help you look at other management and governance tools and observability tools inside of AWS. So in the lab, we'll create a CloudWatch agent configuration. We'll push the CloudWatch agent to our EC2 instances. We'll configure that CloudWatch agent to capture metrics and logs, especially for our IIS servers. And finally, we'll configure automated response for CloudWatch events. So with that, let's jump into our lab. Okay, hopefully you have all the links to get access to the lab. What I'm going to do right now is walk through these labs first by kind of familiarizing yourself with the environment that's in the lab. So everything that was deployed in the lab was deployed via CloudFormation. So if we take a look here at my screen, obviously the name of your stack name, the first part of it may be different, but we want to focus on this second part, which is workshop instances, and here AD stack. And so what we have is a parent stack that deployed a bunch of nested stacks, a new VPC, as well as Active Directory, a management server which we'll RDP later in the lab into to be able to see Active Directory and manage Active Directory, and finally the workshop instances, which includes a load balancer and 2 IIS web servers that are behind that load balancer. If you click into each one of these, we want to click into the workshop instances and go to outputs. And first we want to copy out this DSC bucket so we have later for our third module. Also, if you click on the AD stack, you'll also want to click out here or copy this out, the AD secrets ARN, because we're going to use that in module 3. So you may want to copy those and put them to a notepad, but just note where they are, where you can come back to get that information. Let's go over to our EC2 console. And just a quick note, you can search for any service here in this top bar. So if I go to EC2, I can click on EC2 and come to the EC2 console. Later, when we come to Systems Manager, you could click there, type that in, and click into here and get started in Systems Manager. But what I've done is I've went ahead and opened up all these services in different tabs at the top of my web browser, so I have quick access to each one of them. Also note that in our lab environment, we'll be working in the Ireland or EU West 1 region for all of our lab work. And as you can see here, I have multiple instances. I have a management instance, a Web 01 instance, and a Web 02 instance. If I click on Web 01, let's just take a note of some of the tags here, because we'll be using these tags to use run command quite often using the tags that we have available. So if you note here, we have a tag that has name. We'll talk about this in our module 3, as well as the tag domain. We'll make use of them in module 3 when we're trying to join the Active Directory domain and we talk about tokens. We'll be using the operating system tag in our patch management lab. And for many of the commands that we run, we will be focusing on the role web server. Now I could also go and create resource groups using any one of these tags, and it'll automatically focus on those instances. And tagging would be a best practice, is making sure that you have good tag discipline and you use these tags for either targeting for management or reporting on cost inside of AWS. Now that we've kind of looked at the lab environment, we have an understanding. As I mentioned, we have a load balancer here in the front. So let's go here and let's see what our web server looks like. So if we click in load balancers on the left hand side of the EC2 console, you'll see that there's one here that says my load. So we want to click on that one and we want to copy the DNS name. So this is how we were going to our web site. So if I go ahead and copy that, and now I go to Chrome, I'm going to go ahead and paste this in and let's see what happens. Oh no, something's wrong with my web page. It isn't working. So I got a HTTP 503 error, which means this is on the server side. So something's wrong with these EC2 instances that have been deployed in the lab. Let's try to see what that is. So one of the things to note is that we'll use a lot of run command, and I would recommend using run command to bootstrap and install software inside of your EC2 instances. But in this case, in the lab, we used user data, and user data was trying to install IIS. So something's wrong with our user data, obviously, if IIS is not set up correctly. So let's go to right click on our Web 01 server, go to instance settings, and then we're going to look at edit user data. So we see that we're running a PowerShell script. We're using the install Windows feature. That looks good. -name. I mean, that kind of all looks good to me. We're also adding content, which is a trace page, and then we're basically deleting that IIS start page. So I'm a little bit at a loss still what's going on. So user data generates logs locally, and right now I don't have any kind of tool that's capturing my logs or exporting them. So I'm going to have to break the glass here and kind of log into this Web 01 instance to see the logs. So the one way to do that is I can click here and I can click connect. So now what the EC2 service has added is they've added Session Manager directly here so connect into it. The other way that I can get to Session Manager is if I go to Systems Manager, and under Node Management, which a lot of the things that we'll do today will be under Node Management, we'll click on Session Manager. And here I can start a session. If I go ahead and start a session,
I'll click on web01 and then say start session. So if I did that here, it would take me to the same place. So here we see instance name web01. Now I'm right at the PowerShell console of that instance, right? So I'm effectively on the local instance and I'm going to execute this command. So if I want to get the user data logs in our lab, we're going to use the get content PowerShell commandlet pointed to program data, Amazon, EC2 Windows, launch, log, user data execution log. And right here, we see a message. It says the error is from the user script, install Windows feature. The argument's not valid. The role service or feature name is not valid. Web server. Oh, that's right. I need to have a dash between web and server. So we see that I made, or not that I made, but in the lab, we've created an issue with the install of IIS because we need to have a dash between web and server. So now if I had 1,000 servers, I wouldn't want to log into each individual server to remediate this. So how could I remediate it at scale? Well, that's where we go to Systems Manager and we look at run command. So now just to clarify, we've used Session Manager. So we break glass, we got in, we were able to pull logs and see what was going on. And now we're going to use run command to actually remediate the issues in our environment. So if I go to run command and I click run command, as I just did, you'll see that there's a bunch of command documents. So as I mentioned previously, the heart of Systems Manager is really run command as well as the SSM agent. So there's a lot of times where we'll use other services and they will depend on this underneath the hood. And run command also depends on what's called command documents. So command documents can be viewed as an automation script that happens inside of the operating system. And we'll take a look at a command document in a moment. But here we want to select and search for the AWS run. Oh, I want to do an equal run. And I'm just going to do the run part and do a search. And you'll see that's a bunch of documents. One is run Ansible playbook. We have another one here called run patch baseline. We'll take a look at that later. But the one that we want to focus on right now here is run PowerShell script. So if I select that, it will then change what the parameters are available to me. And from the lab documentation, I'm going to copy out the three commands. So here we have our install Windows feature command. I've fixed the web-server here. And if we keep on going, so this specifies the commands. Each command document will have different parameters available. So here in the run PowerShell script, it's just a command block. I can drop in any PowerShell script that I want to. And then targets, I can choose targets manually. Again, if I was doing a lot of servers, this would not be a tenable solution. I can choose a resource group, which is essentially something that I've already predefined via tags, or I can specify the tag. So in this case, we're going to use the role tag, and we're going to put in web server as we did before. Whoop, and I spelled that incorrectly. So let's just make sure that I have that spelled correctly. I'm just double checking to make sure. Good. Because that tag is how we're going to pull our servers. And now I've added the tag. In run command, I can also control the rate. So I could do 50%. I could do a percentage of targets at a time. I can do a number of targets at a time. So I'm going to keep this at the default of 50 targets because I only have 2 instances in our lab. I can also set an error threshold. So if one error happens in any of them, this run of run command will stop. And that way, no more of the targets will be impacted. But here, I'm just going to, again, leave the defaults. But just keep in mind that when you use run command, you have different controls in terms of how many instances are impacted when you do your run of run command. Now, in the output section, you can output the standard out. So anything that's going to happen at the PowerShell console, basically, can be pushed out to S3, an S3 bucket, so I can take a look at what happened on this instance or what happened on this failed node if I was using run command across many instances, or my favorite is pushing it out to CloudWatch. So what I'm going to do is I'm going to enable CloudWatch logs, and what's going to happen is that there's going to be a log group by the name of AWS run, the name of the command document, AWS run PowerShell script. And if I wanted to kind of start to learn what the command line might look like for this, I can take a look here at this command line section. So every time you run command from the console, you can copy this out, modify it as need be. And I'm sure a lot of Windows admins have command lines saved in some Notepad Scratch file somewhere. So you can do that with this here. But I'm going to go ahead and click run. And now this is going to take a couple of minutes. It's going to take about 3 to 5 minutes. So instead of kind of sitting here, I'm going to use the power that I have over time and kind of speed this up. Okay, so using again, what I have over time, we see that I was able to push the time forward and we have a success here for our targets. So I look at the start time, you'll see that 12:31 is when it started, and then 12:34 is when it finished. So it took about 3 minutes to install IIS and to do the configuration that we want. I can also see here, once this is finished, the command description, so I can see what command document I ran. I also have a command ID, will help me from a troubleshooting perspective, and all the parameters that I included with this run command here once I've executed it. If I want to get information on the logs, I can click into one of the instances and you see that the standard the output is here. I see that success, restart, I have an idea of what's going on. If there's a more complex command that I was running, obviously I would see all of that. And the command output displays a maximum of 48,000 characters. So if I had more than that, then I can output to CloudWatch logs, which I did here. So if I go to log groups, which will come back later, we see that I have very few log groups here, but AWS SSM, AWS Run Powershell script, which is what I just ran. I have 2 log streams because each one is a different instance. So if I expand that out, I can click into one of them. And what I should see is the same output that I had from the console. So again, if I push my logs to S3 or I push them to CloudWatch, however long that log file is, I can then do more verbose investigation for any advanced command that I was running. Now, did this really fix our website? Well, let's go ahead and pull up our Chrome browser and refresh. There we go. So now we have our trace page. So we see that I was able to fix what we had wrong with our instances, and everything's back up and running. So this really shows in this lab module how we can use Session Manager as break glass to get into an instance and to troubleshoot, maybe gather logs that we haven't captured yet, or just kind of see what's going on the instance. And we can use run command to be able to run remediation at scale, to install software, or to do any other troubleshooting tasks that we want. So, so that's what we kind of viewed in our first module. So with that, let's jump into our second module, which is how do we patch our Windows estate inside of AWS? So to do that, let's get started by going to Systems Manager. And in Systems Manager, under Node Management, we have the Patch Manager. So I'm going to go ahead and click on Patch Manager. And we see that there's kind of no information right now. I don't have this set up in my Ireland region. And on the right-hand side, you'll see that there's Patch Now, Configure Patching, or View Predefined Patch Baselines. So what this really is on this side is basically wizards to help us quickly get started. The Systems Manager team has a bunch of widgets such as the Quick Setup Wizard as well that kind of helps customers get started pretty quickly using AWS Systems Manager. And really the things that you need is you need to make sure you have SSM agent install on instances. There's a role. You can take a look at the role in the CloudFormation templates that we have or in our documentation. And that role needs to be either assigned to the hybrid instances that you're managing on premises or attached to the instances inside of AWS. And that gives the ability of the SSM agent to talk to the Systems Manager API and report itself into the service and be managed or become what's called a managed instance. So that's kind of what we have there. But in this case, for Patch Manager, we're going to click on the Configure Patching. And the reason why we're going to do that is because this wizard helps us to do 2 things. When we patch inside AWS or on premises, whatever it may be, we definitely don't want to patch in the middle of the day when traffic may be going to our workload. So when we do patching, we usually do it within a maintenance window. And we all know what maintenance windows are. And in Systems Manager, maintenance windows are supported by software constructs. So you can set something that says between every Saturday between 11 o'clock in the evening to 2 o'clock in the morning on Sunday, I want to run my patch management, or I want to run these particular scripts or actions, whatever it may be. And so in the maintenance window, it will run those actions, and then you have a setting where you can say, an hour before the end of the maintenance window, stop terminating actions, right? So that way it gives time to catch up, and then you make sure that nothing's happening outside of the maintenance window. So for patching, you can create a patch schedule here. But first we have to target instances. So why don't we go ahead and select the instances that we want to target. We can do that by patch group, and what you'll note here is I have two patch groups. One is webinar Windows, the other one's Windows, and I can assign that. We'll take a look at what patch groups are later, but patch groups are basically another tag that we can use to target our instances. But in this case, we're going to use a specific tag that's attached to our instances, and I'm just going to copy it out of the documentation or from the lab guide. And so that tag is operating system, and tag Windows. Now, I would recommend to try to keep your patch groups and your patching schedule, like kind of keep that consistent. But this just highlights that you can have different tags to target different instances that may be part of the same patch baseline, which we'll talk about in a second. So you can independently manage what baselines are attached to instances from what instances you target. So in this case, I'm going to use a specific tag to target the instances, and then we'll create a patch group later and show you how to do that process. But if I go here, I just would click add. So now we have our tags as part of this. As I mentioned, we can have a patch schedule, but in this case, because we're doing this in a workshop or a lab, we're just going to go ahead and skip scheduling, which means that these instances are going to be patched right now. In terms of patching operation, what happens underneath the hood, as I mentioned before, is that there's a command document that's run against our instances called AWS Run Patch Baseline. That Run Patch Baseline command document runs in two modes. You can scan so that you report on compliance of your patching, whether you meet what patches are missing, or you can do a scan and install. So it's very common for customers to do the scan on a more frequent basis, maybe weekly, could be daily, depending on how you want to get that information. And then the scan and install is done via a maintenance window. So for purposes of this lab, I'm not going to run the scan and install. I'm just going to run the scan because I want to show you kind of the dashboard and compliance that happens, and the scan action happens a little bit quicker. So in the lab, you'll be able to get that information a little bit quicker than if you did the scan and install. So I'm going to go ahead and configure patching. And what that's going to do is it's going to bring me right back to the patch manager kind of console. So if I want to take a look at the dashboard, right now I have no information. So they've never reported compliance. That'll change in a minute. I can also, here in reporting, I can export to S3. I can take a report and it'll create a CSV file or some type, create a report that I can then provide to management that says, here are the number of instances that are not compliant to our patching schedule or patch baseline. So you can easily get some reporting. We'll take a look at patch baselines in a second, as well as patch groups. You'll see that here I have two patch groups defined and two different patch baselines for them. We'll create a patch baseline in a minute, but I just kind of wanted to take a real quick tour of that while the run command runs in the background. So let's go ahead and go over to run command. And we see that we have this AWS Run Patch Baseline document that's running. It's in progress of running. So if I click into the command ID, we see that I'm running against my two web servers, or what we know to be our web servers at this time. So I'm going to go ahead and while this is going, I'm going to go to Documents, and we're just going to take a look at, so on the left-hand pane under Shared Resources, there's this Documents tab. And this is where you can find all of the documents available to you out of the box provided by AWS, such as AWS Run Patch Baseline. So if I type AWS Run Patch Baseline or Run Patch, you'll see that there's 3 command documents that come back. If I click into the Run Patch Baseline document that we're running right now, I can see a description of that command document. I can look at the content. So this is the actual script that we're running against the SSM agent. So I can copy this out, make changes, create my own Run Patch Baseline if I wanted to. And then there's versions. You see that I don't own this document. If I go back to Documents, if I click on Owned by Me, you'll see that there's 2 documents owned by me. Now these are automation documents in this case, which is a little bit different than command documents, and we're not covering in this lab, but I strongly recommend that you take a look into automation documents because there's some interesting stuff that you can do. So if I do AWS, for instance, migrate, if I spelled it correctly, you'll see that I have one here that can migrate the CloudWatch agent, and there's different documents provided by AWS support to do various different things. There's documents provided by the AWS EC2 service team. So I can even do AWS EC2 and kind of search what they have. So this kind of gives you a good idea that if there's some type of task that you're looking to run, I would definitely recommend searching what's currently available to you, using that to get started. A perfect example is the EC2 provides something that runs sysprep against instances. We also have, create a VSS snapshot. So there's a lot of other good kind of command and automation documents in here already available to you. So after I've shown that, let's go just take a look at how our patch baseline is doing. So that's still in progress. So we'll click here, and we're going to use again, my powers of being able to fast forward time and come back when this is successful. Actually, what I decided to change my time while this progresses, why don't we take a look at creating. So one of the questions that you may be thinking is like, okay, well, how does he know which patches are going to work or are going to take effect or get installed? Or how can that be controlled, which is a very common question. So let's go back to Patch Manager. And what we'll do is we're going to click on View Predefined Patch Baselines. So one of the things that we have here is, again, out of the box, there's some default patch baselines. What that means is that if there's not a patch baseline that is assigned to an EC2 instance, or assigned to a managed instance, I should say, because there's a lot of customers that also use Systems Manager to manage their on-premises systems, then it will default to one of these patch baselines, the one to say yes. So in this case for Windows, we'll see that there's this default patch baseline. And if we click into here, we can see that the rules are anything that's critical or important, a critical update or a security update that's in existence for 7 days will take effect. Well, that may not work for you. You may want to have more granular control of that. And that's good. That's okay, because we can go to patch baselines and we can create a patch baseline. Now here we'll say webinar 2 patch baseline. We can name the patch baseline. We can say what operating system we're going to run. This is a Windows workshop, so we're going to focus on Windows. And if I wanted to replace that default patch baseline, I can click here, and then this would be the one that would take effect. But in this case, I actually want to really target to specific instances different approval rules. So as I create this patch baseline, I can specify what product. So I don't want all the products. I just want to focus on 2019 server and 2016 server. In terms of classification, I want all classification patches. So whether it be a driver update or anything like that, but I want to focus on the severity. So I want critical, I want important, and I also want moderate. So I want a little bit different than what is specified in the other patch baseline. And what's also going to be different is my approval rule. So I'm not okay that 7 days, keep on floating forward. I kind of want to freeze date patches to the previous Patch Tuesday. So I've selected the previous Patch Tuesday, and I want, any patches up until this date will be assessed against my EC2 instances. In terms of compliance reporting, I want to report as critical any missing patches that come up. So here we have our approval rule for operating systems. And we can also create approval rules for applications. And if we take a look at that real quick, this will be pertaining to Windows applications. We have Active Directory, we have Exchange. I can also patch Microsoft SQL or SQL Server, as you can see here, System Center, any of the Microsoft product suite as well. And then set the same type of what products, classification, severity, and then time. But I'm not going to include applications because I don't want to intermingle operating system patching and application patching. I might have two different processes for either or. But I also can control patch exceptions. So if I have a patch that I need to have to make sure that a consumer off-the-shelf application works, I can explicitly define that patch by KB article. Or if there's a patch that breaks an application that I have, I can also define it here by KB article, and those patches will be rejected. And I'm going to go ahead and create that patch baseline. Now, if I go to the second screen, we'll see that I have webinar patch here and baseline. And the way that I assign patches to or instances to this patch baseline is I would click the patch baseline, go to actions, and say modify patch groups. Now, one of the things to keep in mind with Patch Manager is that in order to have this patch baseline to take effect, we need to have a tag assigned to our EC2 instances with the key name of patch space group. The value can be anything that we want. So in this case, I'm going to say webinar 2, and then any instance that has that tag of patch space group, webinar 2, will be assigned to this patch baseline. And when I run the patch baseline command document or assessment, then this patch baseline will be in effect, and that's how I can control which patches are assigned to our EC2 instance. So let's go back to the dashboard, because if we take a look at run command, and we'll take a look in a second, we see that our patches have finished and our dashboard's been populated. So what we see is that we have 2 non-compliant instances. So that means that 2 of the instances that I ran the scanning on do not have. We can also take a look at the operations that ran. So we see that I ran some scanning and installing in the past couple days, or I ran some scanning yesterday, so we can see the patch history here as well. And if I go to reporting, we'll see that I have 2 non-compliant EC2 instances, right? Web 01, Web 02. I can click in here and kind of see, what's missing. So we see that there's 1 patch that's missing. It's a critical security update patch that I need to make sure gets applied. So I have that up to that granular of information that I can pull. And again, I can export or report to S3 if I needed to provide this to management in any kind of shape, form, or fashion. So now we've covered how in Patch Manager I can get compliance reporting on my patch levels. I can also install or scan my patching, and so I can handle patching my estate at scale using Systems Manager. Okay, so now that we've done configuring Patch Manager, what about if we want to see what's installed in our instances in terms of software? How would we get that? Well, if we go under Node Management, and we can click on Inventory, what we can do is, I already have inventory configured here in my account. So you see some of the information that inventory can provide you. You'll see that you have OS versions, applications, top 5 server roles, top 5 services, the instance IDs that they're getting that from. But if you want to set up an inventory so that you can have that information, there's a lot of interesting things that you can do with AWS config in terms of config rules to get alerted if there's a piece of software that you don't want to have installed, and then trigger a remediation via AWS Systems Manager automation to uninstall it. You can do a lot of kind of advanced stuff, but a lot of customers want to know what's installed in their instances. So to set this up, we click on Setup Inventory. Give this a name. We can specify a tag. So in this case, we're going to specify a tag again, operating system tag, and we're going to do copy and then Windows to specify a tag in this case. But what you can also do is, and what I would recommend is, just select all managed instances in this account. So instead of doing it by tag, you could just keep select all managed instances. The other inventory setup that I have is doing it on all instances that initiate into the account. And then we keep the cron schedule, or the schedule, to be every 30 minutes. We can change this to be every day, as well as every couple of hours if we want. And here's how we control what information is being collected. So you have applications, components, network config. We'll keep all this default, but you can also add particular files. So if you want to collect a specific exe, or to see if there's a log file or an INI file that exists, you can add that. Or specific registry keys. So if you have custom registry keys for an application that you maintain and you want to kind of make sure that it's, amongst all the servers, again, you can use this in inventory. There's also custom inventory that you can add. In our documentation, it shows how to add stuff like, there's customers that do rack or row in terms of their on-premises data center, so that you can also add that information. And then you would go ahead and click Setup Inventory. What that will do is that will create a state manager association, which we'll talk a little bit about in a second. But here you'll see that inventory association, AWS gather software inventory. And so that state manager association gets set up, and it'll start to collect the inventory or the information that's on the instances. Now, all of this information gets aggregated into Fleet Manager. So under Node Management, if you click on Fleet Manager, we can see all of that information aggregated by a particular instance. So if I click on the Web 01 instance, I can see the tags that it has. If I click on inventory, I can see all of the software that's installed on it. Here, inventory type is AWS application.
So these are just focusing on applications. But if I click and I wanted to see, let's say, for instance, what Windows roles were installed on the server, I could take a look and I can see what Windows roles are installed on this actual web server box, and kind of see all the things that have been installed from that perspective. So we see that there's a lot of services installed on this particular Omni image, apparently. And then if we take a look at associations, I can also see what associations are running or pending. So here we have some pending associations. I'll walk through how to set this up. We see that it's already pending, so it's already kind of running on these machines. And then in terms of patching, we could take a look at Patch Manager and also see what patches are there, as well as the configuration compliance. If we want to take a look at performance, user groups, or other items, we can do that as well. So that's how we can take a look at inventory. So now we've taken a look at how we can do remote management. We can use Session Manager to break glass, use Patch Manager to patch our Windows instances, and also use inventory to collect what software and what's installed on our instances as well. So why don't we look at scaling Windows management and how we can make sure these are joined to the Active Directory domain. And one of the most common tasks that us as Windows administrators are responsible for is to make sure that an instance is joined to an Active Directory domain. So if we go back to instances, the first thing that we're going to do is we're going to log into our management server here. And so if we click on management, one of the things that you'll see is that this is sitting in a public subnet in our lab. So we can go ahead and copy this public DNS entry. And then I'm going to go ahead and open up RDP. So let me just get RDP open. Okay, opened up in another window, so I'll move that over. And we will paste in this machine. Now, as part of CloudFormation, as I mentioned before, we auto-created the password. So if we go to Services and we type in Secrets Manager, we use Secrets Manager to do that. And Secrets Manager is also storing the passwords that we have. So if we go ahead and open Secrets Manager, you'll see a secret name called AD-admin secret. I can click into that and I can retrieve the secret value because I have access to it. So we see that the username is example admin. So that's the domain NetBIOS name as well as the username. So let's go ahead and copy this password. So now when I RDP to this management server that we're kind of connecting to in the lab, I'll get prompted for that information. So I'm going to put example /admin so I can log in and then paste in the password. And we can connect. Now there's a way that you can use Session Manager to port forward to RDP, but for simplicity's sake, that requires the AWS CLI to be installed locally as well as a Session Manager plugin. We have documentation that shows you how to get that set up and how to use that feature, but I just wanted to give a quick, easy way to get into RDP so that we can take a look at Active Directory. Okay, so once we're connected to this management server, let's go to our tools and open up ADUC, or Active Directory Users and Computers. Let me open Active Directory Users and Computers. We're in example.com domain. We'll look at the example OU, computers OU, and then here we have management. And we notice that our Web 01 and Web 02 servers are not in this domain. So we definitely want to fix this. We want to make sure that we're consistently adding any of the instances that join our AWS account to this example.com domain. So in order to do that, what we're going to use is we're going to use Powershell DSC, and we're going to generate a MOF file from Powershell DSC. So let me go ahead and open up VS Code. Now, one of the things that I want to point out in this PowerShell DSC script here is we have this section here called configuration data. Now the configuration data speaks to how the local configuration manager in PowerShell DSC works or operates. And so one of the key things that we want to make sure is that this allow plain text password is set to true. So we want to make sure that we can use that. Now, typically as best practice, it's not what you would want to do in PowerShell DSC, but inside of AWS, that's okay because we're going to use the AWS Apply DSC MOF document. And the AWS Apply DSC MOF document, we do a couple of things to process a MOF in a secure manner. And one of them is we provide the ARN here. You'll see that in the configuration section of the PowerShell script that I have here, and this is kind of dictates what creates my MOF. So this function configuration that I'm calling domain join, and then in this body I have all the things I want to do. So you'll see that here I'm creating a variable That's just called shared secret or SS. And here I'm converting a string to doesn't matter, right? So I'm just doing this because what's expected to create a credential object in PowerShell, right? So for me to successfully create this DSC file, I need to have this. But the string doesn't matter because here in the credentials part, you'll see I've put the ARN of the secret that I have in this lab, right? So you're going to copy your ARN and you're going to replace this section here. And then obviously the SS. So when I create this credential object, what's going to happen is the apply DSC mof document is going to see this ARN, and it's going to go and grab the password from the API programmatically from Secrets Manager. Here I have this import modules. This is kind of the modules that I'm going to be using. I just kind of have them both here as an example of what are the modules that are in play. And so this is also important because in the AWS Apply DSC mof document, it will also automatically install or import these modules. So if they don't exist, it'll go to the PowerShell gallery and install them, or it'll go to an S3 bucket where you've defined where your modules exist and get them installed. Now here is the actual configuration in PowerShell DSC for my particular node. So I call it localhost. Here I want it to join the domain. And one of the things that we want to note here is this use of tokens. So you see I'm having a token here that says tag : name. What this means is that as the apply DSC mof document applies the configuration, it's going to look to the EC2 to grab the name of this EC2 box based upon the name tag and rename the operating system to match. And here in the domain name, it's going to pull the domain tag to join that domain. So in this case, it would be example.com as we had shown before, name and domain. Attributed, they're going to fill in here and then apply this configuration. So now we have using these tokens that are provided by the AWS Apply DSC mof document, I have a very flexible configuration, right? I could apply this to 1,000, 100, whatever machines, and I'm controlling things based upon the tags that are assigned to them. Now this section, we're not going to demonstrate what it actually does, but I put it in here because this is showing security. So this is something that's typically done via GPO, making sure that there's an interactive login message, for legal purposes. And so here, I'm not putting it in the mof file, but you know that I'm grabbing it from SSM parameter store. So what this is, there's a parameter in our lab environment that's called logon message. And in there, there's a text string that will be, again, replaced here and then configured on the local Windows box. And then I'm going to run the command domain join output path. This is going to path locally to my machine, which I've already done. And once you do that, we're then going to go to that directory and we're going to rename it. So it's going to say localhost. You'll rename this to Win Workshop. And then that way, when we upload it and we refer to it in the next step that we do, we kind of know where it's at. So go ahead and rename this to Win Workshop, and then you want to upload it to the S3 bucket that we have. So what I'm going to do is let's go back to documentation. And just real quick before I jump there, what it generates is something that looks like this. We also have this in the documentation. This is an ASCII text file. This is what the LCM will read in order to process configuration. But in our case, using the AWS Apply DSC mof document, we obviously will process this ASCII text file for you and then orchestrate between LCM the configuration. Now if I jump back into our portal, let's go over to S3. I think I already have it open in one of these. Oh, I do not. Oh, here we go. There, here we go. Here's the S3 bucket that we have. So you're looking for an S3 bucket that's going to have something with the name of DSC bucket. As we did earlier, we copied it from the output. So let's go ahead and upload our Windows Workshop document. So I need to go to my documents, PowerShell. Here we go, and open. And now I'm adding that file. I'll go ahead and upload that. So now I've uploaded to S3 my configuration file. I can have 100 machines point to it, 1,000 machines point to it when I create my state manager association next, but it's ready to go. So let's jump back into Systems Manager. So we'll go here, go to Services, Systems Manager. I have it favorited. And we'll go to State Manager. Now, State Manager, what this does is that they can run an association. We're running an association here to gather software inventory. And what's happening is that we're running the AWS gather software inventory document name on a schedule, right? So it runs it every so often. In State Manager, there's two things. We can use it to apply configuration or report compliance. And so here with the apply DSC MOF document that we're going to set up our association with, we're going to report on compliance, but we're also going to make sure that these are joined to the domain. So let's go ahead and create that association. And we will call it, I'm trying to match up and make sure that I keep the same names as in the documentation that you have. Oh, and just one quick note, inside of the documentation, before you run that PowerShell DSC script, you want to make sure that you actually install these DSC modules locally on your machine. So I had already done that in my environment. So this step you definitely don't want to miss. So once I've generated them off, let me just pick up what we call this document. So we're going to call this Win Workshop. And we will select, so right here at the documents, you'll see that here is AWS Apply DSC MOFs. And in this section, since we're pointing to an S3 bucket, what we want to do is we're going to do S3 colon. So we're going to use a unique naming path to our S3 bucket and to our object. So here I'm going to paste my bucket name. And then the name of our object is winworkshop.mof. Make sure I type that correctly. In the MOF operation mode, we're going to set it to apply. So this will correct non-compliant resources. If I just wanted to report only, I would put report only, and then it would just let me know which ones don't meet to my compliance. But in this case, I definitely want to apply this configuration. Here I can define a module source bucket name if I wanted to. In this case, I'm just going to go ahead and say allow PS PowerShell gallery module source. So in other words, if any of the DSC modules don't exist, the apply DSC MOF document is going to make sure that those modules are installed so that the MOF file can be applied correctly. In terms of reboot behavior, we're going to reboot after the MOF. So basically this is going to try to process as much configuration as it can and then reboot after the MOF has been configured. I can also say immediately. That would mean that at every turn that DSC reports back that a reboot should happen, it will happen, and then continue to process that MOF, or I can suppress reboot altogether. So in this case, I'm sticking with the after MOF reboot behavior. Under compliance type, this is important. So when we look at compliance, we'll create a tag that says custom and then DSC, and this is how we'll understand whether our machines are compliant or not. And if there's any pre-boot scripts that I want to run, I can specify it here. We're going to continue to use the same tag name and value that we've been using of role, web, and then web server. And I'll go ahead and add that. And then we can specify our schedule. So here you see that the default is association run every 30 minutes. This will be slightly different than what you see in the lab documentation, but we can change it to be hourly, daily, whatever it may be. But because this is a lab, I'm going to keep the default for every 30 minutes. But in State Manager, you can also say no schedule. So what this means is that State Manager will process it once, and it will try to process that association successfully once, and then not run it again. So I can pick either or. In this case, I'm going to say no schedule. So I'm going to want it to process once, join it to the domain, report back on compliance. But typically I may go back and set up another State Manager association that's report only. So that way I can get an understanding of whether it's drifted away from that configuration. And in terms of compliance severity, I'm going to say this is critical because if it's not an Active Directory domain, I don't have my GPOs applied, or I don't have, any of the number of things that I might have going on in Active Directory on my OUs. Again, we have the same rate control options that we had previously. And then in terms of output options, if I want to output these logs, I can paste in my bucket name that I have, and then a prefix of logs. So that way, any of the logs that are generated in the processing will go to a particular logs bucket folder, and I'm going to create that association. So now this association is pending. Let's click into it and make sure that we have some targets. Or some resources. So we have two resources. We have these two instance IDs. What that means is that we'll be processing. If we take a look at run command, what we should see, yes, we see a command ID, AWS Apply DSC MOF is in progress. So this is starting to process. So we'll give this a couple minutes, and then we'll see if we're joined to the domain and if we're compliant now. So let's see how long that takes. Okay, so now we see that our this document ran successfully. It took about 4 minutes to make sure that it meets standard. If we click on Fleet Manager, and we take a look at Web 01, and we take a look at associations, we'll see that that association was applied successfully. And if I look at configuration compliance, I can see that my MOF domain join is compliant, and my login message is compliant. So I can see that each one of those items that I had, so the entire MOF is compliant, as well as each section. So if one section of that MOF document failed or didn't meet compliance, then I would be able to know and be able to get that specific, granular part of it. Let's just double check that by going back to our management server, and there we go. Now we see Web 01 and Web 02 are joined to our domain. So we definitely can see that this, really helps to scale this out if there was 100 machines or thousands of machines, or if we were adding Active Directory, if we were adding machines, Windows machines via auto scaling, we could use State Manager as a way to ensure compliance or ensure configuration in terms of being joined to our domain. Okay, so now we've covered most of the scaling and configuration items. Now let's jump into logging or setting configuration for monitoring. And so to do that, the first thing that we're going to do is, now I'm not going to walk through the part that's attaching a role so that we can generate the configuration. But if I go to parameter store, so one of the things that you'll see in parameter store beside is my login message, but also in parameter store, I've already gone through the wizard, right? So in the lab, you'll log into Web 01. You'll then run the configure package. I'm going to install the package now, but you're going to then, after you install the CloudWatch agent, you will run through the configuration wizard for CloudWatch, which will generate and push to Amazon parameter store this value. So this value information says what logs are we going to collect. So we see that here we're going to collect the IIS logs. We're also going to collect Windows events and also metrics, right? So any kind of metrics that we have will also be collected. Logical free disk space, memory that's committed, paging file, physical disk metrics, processor information. So when you go through that CloudWatch configuration, which I'll kind of launch right now just so that we kind of know how to do that. So if I go to instances, we'll click on Web 01, and then we'll look at the IAM role, and that'll take us to the IAM role. And in the IAM role, we already have, if you take a look at the roles that are attached, we already have the CloudWatch agent server policy. So this policy allows CloudWatch to be configured and also to push logs and metrics to CloudWatch. But what we want to add here while we do this configuration is we're going to add the CloudWatch admin policy, which allows writing to SSM parameter store. So I'm going to just check that, attach that policy. I'm going to come back and remove it when I'm done, because obviously I just want to use it to generate the configuration. Let's go back to Systems Manager, and we're going to use run command to install the CloudWatch agent. So let's go to run command again. We're going to click on run command. And then we're looking for the AWS configure AWS package. So here, we're going to click on that command document in particular. In terms of actions, we're going to keep install, uninstall, and reinstall. There's a bunch of AWS software that you can install, stuff like the inspector, Amazon inspector. But in this case, we're going to install Amazon CloudWatch. I'll go ahead and put that name in there. And then we're going to specify our targets. Again, we're going to stick with the role and then web server. And we'll click on add. And we will push our clouds to CloudWatch, and we'll go ahead and run that. So this should happen very quickly. And that's going to install the agent to each one of those, both Web 01 and Web 02 in terms of CloudWatch. So that happened pretty quickly. So we'll go ahead and now what we're going to do is I'm not going to walk through the whole thing, but I'm just going to at least get you started so that you know how to do it. So in this case, we're going to click on Web 01. We're going to say connect. We're going to connect back in using Session Manager. And then we're going to change our directory. So once we're in there, I'm going to go ahead and copy the command that's in the lab, which is change directory to where the CloudWatch agent is. Now, once that's installed, I'm going to go ahead and run the config wizard. So as I run the configuration wizard, it's going to ask me a bunch of questions. So I'm going to say, keep the default. It knows that it's Windows. It knows that it's on EC2 on-prem. We do not want to turn statsd on. So we're going to say no to this. We're going to say 2. We're going to go ahead and keep the existing log agent configuration file. We're going to say 1 to host metrics. We're going to leave all the defaults here and kind of walk through this. So yes, the default here and the default there. Here we're going to go for advanced. So when it says which default metrics config do you want, we're going to select advanced. And are we satisfied with the above configuration? So, yep, I am. That's for metrics. Do I want to monitor any customized log files? Yes, I do. And so I'll go ahead and copy the path from our lab and we'll paste it here. So I want to correct our IS logs, default choice, log group name. I want to call them IIS logs. And then I want to call the stream IS log streams. Do you want to specify any additional log information? And I'm going to say specify 2. No. Do you want to monitor any Windows event logs? And here I'm going to keep the default of yes. And I do want to do system logs. I do want them to be verbose. So I'm going to say verbose yes. So that's the default. And information levels, yes. And also warning levels, yes. And error levels. So I want all of these goodness. We'll keep that to yes. We want critical as well. And then the log group name is going to be system. And for the log stream name, we'll keep the default, which will be the instance ID. And the log format we'll keep as XML format. And do we want to specify any additional Windows event logs? And the answer is we do, because we also want to specify security. So we'll say yes. Sorry, yes. Default choice. So here in this case, we're going to type in the security logs. And then we're going to hit enter. And then say, keep the defaults here again, information levels, warning levels, error levels, critical levels. Default choice is the log group name will be security and the instance ID. That's good. And we'll keep that. And we also want to specify one more additional log. I believe, nope, I think we're good. Yep, that's we're good. We've got security, event, and that's it. Just wanted to make sure. And so we'll say 2 here. Now here it's asking me if I want to store this in SSM parameter store. I'm going to say, yes, I do. And you're going to keep this name, Amazon CloudWatch Windows. I already have this, so I'm just going to go ahead and create I'm going to copy this. I'm going to copy it from over here, sorry. I'm going to copy it and change the name at the end. So that way I know that it's what I did here. And Windows 2 for me. Okay, enter. Default choice is the region that we're in. Yes, I'm going to use these credentials. Okay, and enter. All right, so now I'm done. So I went through the wizard. We just wanted to show you how to generate that configuration, which we just did. And I'm going to go ahead and terminate this session. All right, so now I have a configuration file. If I go back to Systems Manager, now you kind of understand where I got that parameter file from. So if I go here in parameter store, if we refresh this, we'll probably see it in a second. I think, you will see this, and then this is the configuration that's there. All right, now let's configure. Let's go over to CloudWatch real quick. So we'll close these. And what I'm going to do is I want to take this policy off now, since I don't need it anymore. We still have all the other necessary policies for that. And then we'll move over to CloudWatch. Let's take a look at our log streams real quick, because that'll be the easiest way for us to know that this configuration is working. I'm I'm actually in a different region. So let me move over to Ireland, EU West 1, which is where we have our lab. And you'll see that I have from my run PowerShell script and my configure AWS package, but I don't have any of those IIS system logs or any of those other logs. So now what we're going to do is we're going to use Systems Manager to configure CloudWatch. So let's go back to run command. And when we go to run command, we're going to go ahead and look for I'm going to copy it out of the documentation, but it's called Amazon CloudWatch Managed Agent. So we'll copy that. Click on run command, search for this particular document. Perfect. We'll select that one. And then here we have configure EC2. The source is going to be SSM. So we want to make sure that we put in the SSM parameter store name in the optional configuration location. So this is where we're going to get our configuration for the CloudWatch agent. And so we'll keep the rest as yes, and then we'll specify our target. So again, we're going to go with our handy dandy role web server. Go ahead and add that. So we've gotten a lot of practice with run command today. That's cool. Hopefully it builds your confidence. Again, this is just my preference. I enable CloudWatch logs and I go ahead and run that. Now this is in progress. Let's see, give a real quick, see how long it takes. So that happened pretty quickly, almost less than a minute. And so it's going to take a little bit for our traffic to kind of start to generate to CloudWatch and start to see the logs. So let's just give it a second for CloudWatch to pick up. And let's refresh this. Oh, there we go. Now we're starting to see the logs that are coming from our EC2 instance boxes. So what's happening is the CloudWatch agent has now been configured. It's been installed. It's gathering those logs. If we click into the IIS logs, we can see the IIS log stream. And here's all the logs for IIS, right? So we can see, health checks. So we see that the health checks from the ELB are coming through a bunch of times. We'll see that this was me coming in before to test the website. So we kind of see that there's traffic coming through. And so if there's anything in our log files that we needed to investigate further, we can. We could then use log insights to do different timestamp message and see how much traffic is over time as well. If I go back to the log groups, we can then take a look at also security logs. So we can see for each individual EC2 instance, again, I can do metric filters, so subscription filters. I can then also use log insights to interrogate this a little bit more and graph it out. But we can see all the events that are coming from, those EC2 instances in question. And what about the metrics? So we also collected some metrics. So let's go to the metrics part, and we can kind of investigate this. So if I go to all metrics, we'll see that the CW agent is in there. I can take a look at all the image, instance ID, and we see all of the metrics that are being collected. So if we just kind of correlate, I had a bunch of instances yesterday, so I just want to, so one is ending in 2F, right? So 2F, let's go back to CloudWatch agent, and let's see if our images with 2F is there. This might be from yesterday. So we have 12 different instance names, but we're starting to collect the metrics for our instances. We can then graph these instances. So we see web 01, web 02. I can look at paging files, right? If I want to. There's not much data here, so I'm gonna have to do for 1 hour. Well, nothing for paging file because there's nothing going on. But let's look at logical free disk space. I can change this. This is a line graph. I can just change this to a number. So we see that there's 36% free on this particular C drive in this kind of instance. And I can kind of, take a look at memory and play around with the graphs and kind of get a good understanding of what's going on in my system. So now we're collecting the metrics and the logs for our IIS servers through this lab. And you kind of saw the configuration of that. So that kind of wraps up our lab. Or our set of labs or our walkthrough for the labs. We took a focus of looking at Systems Manager to use it to install software into our instances, rectify and fix software that we had initially installed through CloudFormation. We also have compliance information We also use Systems Manager to make sure that our things are joined to the EC2 domain, and we're also collecting logs and metrics so that we can monitor our EC2 instances and then we can graph them. So with that, I hope that you found this session helpful and beneficial. If there's any questions, please reach out, and the lab will be up as you continue to work through for the next couple minutes. We thank you for your time, and have a great day. And now we're back. So really appreciate your time in following us along with this lab and also this content. And we hope that you found it helpful. Again, please reference those additional resources that are throughout the lab guide. Some of those resources are to documentation, to blog posts, or to other labs that can help you learn more about the management tools inside of AWS and the flexibility it is to manage Windows workloads inside of AWS. Hope you found this lab in this session helpful, and have a great day.